So what about control structures? So, when we're building templates, we need to be able to do looping and if conditions and things like that. So we can just keep going with this example and see what we can do here. Just say we add an accept language so that we're matching on a request that has /hello something, and we want to capture the language. And then somewhere in our code, we want to respond differently based on that language. Again, the parentheses are used to break out. What I really like about this is that parentheses are generally used for any block of code in Scala. This is not different. It's actually just saying, I want a block of code here. And then I just do my if in the normal way. If the language is ENAU, which means Australian, then I want to insert at this point a heading that says, G'day, whoever the name is from the path. How you doing, mate? Else, hello name, how are you? A little more civilized there. How does this actually work? Well, Scala's if statement actually returns values, and Scala will return the last statement of any block. So what's happening here is that there's a node sequence with HTML and body in it, and then Scala is checking the condition. If it's English Australian version, then it's constructing another node sequence called H2 and inserting that node into the parent node if the condition is met. It's actually a perfect templating language. If statement's fine if you've just got two options, but where there's more, there's better ways of doing things in Scala. And again, we just use the case statements. So we have a block of code again at our insertion point in our template, and instead of saying if lang, now we're saying lang match, and then match takes one of these partial functions. So in the case of EN Australian, we respond in the same way. In the case of ENIE, which is Irish, and someone put a URL /hello/Patrick, then we could respond with, top of the morning to you, Patrick, how's yourself? And then of course we can have a catch-all case. And again, the underscores used to say, just match anything at all. And so here we can have a default response. Now I just wanted to say at this point that this is not a very friendly way of dealing with language, and that Punk does support a full I18N type of language snippet resolving mechanism. So you can just say in your template I18N and you pass the code that matches the property file snippet. And that I18N function is already using the language that's been abstracted from the request in the background for you. So let's have a look at a loop. How could we do a loop? Well, again, we'll just say we want a block of code at a certain insertion point, and then we just do a normal for loop. In this case, we're extracting all the language values from the accept language list that our browsers have sent us, and we're going to list them out. You'll notice here that this for loop has the keyword yield. Scala's for loops allow you to return a value, and by using yield, it naturally returns a sequence of elements. So what's happening here is that Scala will go through this for loop and for each one create a new node of li and construct a sequence of those li's, and then insert that sequence within the ul element of the parent node sequence. Again, I haven't written any code to do this. This is out of the box Scala, and it's brilliant. What about response headers? These are very important if we want to be able to control our browser cache or specify the type of content and how it should be rendered in the browser. And also things like response codes are very important. All the standard response headers, including the response codes, are made available in the response object. But looking at this, you might be thinking, well, where is the response object? Scala provides a thing called implicit conversions. What this means is that if a method is called on an object and that method doesn't actually exist, Scala will look for a defined implicit function that might be able to convert the original object into the object that has this function. In this case, there's a method called notModified 304, and that method's defined on the HTTP response object that's provided by Punk. Above that, there's a node sequence, which is straight out of the box Scala. So how is that method called on that object? Well, Punk provides an implicit conversion that says, if you have a node sequence, here's a way of converting it into an HTTP response. So with that implicit conversion defined within Punk, it means that you don't have to manually convert it. Scala is actually joining the dots and saying, I know how to convert a node sequence into a response object, so I'll do that for you. And of course, you can call that method on that object. This is way better than duck typing because it's a type-safe way of doing what appears to be a very similar thing. All of these methods on the response object are chained. They always return a reference to themselves, the response object. And because Scala always returns the last item in the block, then the response is eventually returned from this case statement. What about MVC? What about splitting out the view? It's no good having all the code in one file, is it, for your whole web app? Here's an example of how you could do this, but there's probably more than one way. And this is where Punk doesn't get in your way of factoring your code the way that you like it and splitting things out into a logical structure that meets your requirements. In this example, I've created an object called article view, and it uses a special method name called apply. Now I'll explain how apply works in a minute, but inside apply we have the template, and you can see here that it's pulling out values from the article object that was passed to it. So that article view is fairly self-contained, and you could test it pretty easily. It has input, which is the article object, and it has output, which is an XML node sequence with those values from the object inserted into it. To use this article view, we don't have to specify the apply method name. It's automatic when we just use the object name. So you can see how it's used above. If we assume for a minute that there's some ORM style object called article that can get me an object based on ID, then to render that object, I can just say article view and pass the reference. Scala, not Punk, automatically calls the apply method. I've completely split out my view from my controller, which is what we want with the MVC pattern, right? But that article view could actually be more self-contained because it's still relying on that article object. So probably an even better way to go would be to pass the individual parameters to the article view. This has got a little bit more at the top now, where I have to pull out the values to pass as parameters to my method. And it's a little bit more down the bottom, but it's very self-contained. There's actually no reliance that my view has now on my model. So here, not only have I split out my view from my controller now, but I've completely detached the model from my view as well. I've got a view here that could be tested without even considering what my controller or model are doing. Let's put some of these parameters on multiple lines because I want to show you here what else he can do. Scala now supports named parameters, which is really nice when calling a method. I don't have to pass the parameters in the right order anymore. I can just specify the names of the parameters and Scala will work out the ordering for you. Not only that, again, I can support default values. So for example, in my method definition, I can specify that keywords is a string, but also by default, it's an empty string. By doing that, it means that in some cases, I may choose to not even pass a keywords parameter when I call my method. This gets really powerful then when you're creating views and things like that, where you can pass just those values that are required and leave the others as their default values.